Today we'll be showing how to find the volume of a sphere using two different ways. One way is using spherical coordinates and the other way is using the disk method. And we'll start with the spherical way. So here I've drawn a sphere with parameters r, theta, and phi. And we will construct a set for the region. So we'll say the set E is a set containing rho, phi, theta. So as you can see from the picture here, theta, the maximum angle it could take, is from 0 to 2 pi. So theta is going from 0 to 2 pi. And for rho, we're just going to go from here 0 up to some fixed radius r. So it's going to go from 0 to r. And for phi, we could think of this point here as phi equals 0 and this point here as phi equals pi. So that's going to be from 0 to pi. So the maximum angle phi can take is from 0 to pi. And so this is the region we're going to be integrating over. So we'll have to recall that the volume in not polar, spherical coordinates, it's the triple integral over E of rho squared sine phi d rho d phi d theta. And this piece here, it's referred to as dv, and all it is if I could draw it here, all it is just a small chunk of the sphere. And so now from here we could integrate over a region. So our volume is, we're going to have a triple integral. We'll still have rho squared sine phi d rho d phi d theta. And using our set E, well, rho is going from 0 to r. Phi is going from 0 to pi. And theta is going from 0 to 2 pi. So now we just have to integrate this now. So we have the volume of the sphere is integral from 0 to 2 pi, and then the integral from 0 to pi. If we integrate with respect to rho, we're going to have rho cubed over 3 sine phi, evaluate when rho is equal to 0 and rho is equal to r, d phi d theta. So we're going to have the volume is just integral from 0 to 2 pi, and the integral from 0 to pi of r cubed over 3 sine phi and d phi d theta. So if we integrate with respect to phi, we're going to have the integral from 0 to 2 pi, and then we're going to have r cubed over 3. And the integral of sine is going to be negative cosine. So negative cosine phi, evaluate it when phi is equal to 0 and phi is equal to pi d theta. So now we just have to evaluate at the endpoints. So we have the volume is the integral from 0 to 2 pi. We still have this r cubed over 3 term. So we're going to have a negative cosine pi and then plus the cosine of 0 d theta. So we're going to have a negative, cosine of pi is negative 1 plus 1. So in total, we're just going to have 2. So we have the volume is the integral from 0 to 2 pi of 2r cubed over 3 d theta. And all that's left is to evaluate this theta integral. So we have 2r cubed over 3 times theta, evaluate from 0 to 2 pi. And that just yields 2r cubed over 3 times 2 pi. So the volume is we're going to have 4 pi over 3 times r cubed. And that's the formula for the volume of a sphere. So that's one way using the spherical coordinates way. Now for the second way, we will be using the disk method that's usually learned in Calculus 2. So we'll just draw the XY plane, and we'll just imagine a semicircle with radius r, but this point will be minus r and this point will be r. So we know that the volume of a disk, it's defined to be pi, and then the integral from a to b of r of x squared dx. So from here we know that x is going to be going from minus r to r, and to find r of x, well, we know that x squared plus y squared equals r squared defines a circle with radius r. So from here we could solve for y. We'll get y equals plus or minus the square root of r squared minus x squared. But because our circle is located in the upper half plane, we'll just use the positive root. So we have y equals the square root of r squared minus x squared, and that would be our r of x. So now using the disk method, it's going to revolve around the x-axis, and if we revolve a semicircle around about the x-axis, we'll have a sphere. So we have our volume is pi, the integral from minus r to r of the square root of r squared minus x squared dx. So we have pi, the integral from minus r to r of r squared minus x squared dx. And because the integrand is even, we could rewrite this as 2 pi, the integral from 0 to r of r squared minus x squared dx. And all that's left is to evaluate this integral. So we're going to have 2 pi integrating with respect to x. We're going to have r squared times x minus x cubed over 3. And that's evaluated from 0 to r. So the volume equals 2 pi. And we're going to have r squared times r minus r cubed over 3. So we have a 2 pi r cubed minus r cubed over 3. So we have 2 pi 3r cubed minus r cubed over 3. So we have 2 pi over 3 times 2r cubed. And so this yields 4 pi over 3 times r cubed. So the volume of a sphere is yet again 4 pi over 3 times r cubed, and that's using the disk method. And so that's how to show the volume of a sphere using spherical coordinates and the disk method. Thank you very much for watching.